Welcome, everyone, to a crucial discussion for anyone building robust, scalable systems. Today, we're diving deep into the art and science of architecting for extreme load events. Think about those moments when millions of users hit buy now simultaneously, or a viral event drives unprecedented traffic. These aren't just more traffic problems. They're fundamentally different challenges that can expose every weakness in your system. By the end of this lesson, you won't just understand these challenges, you'll have practical, production-ready strategies to conquer them. We'll explore how to anticipate demand, build resilient scaling mechanisms, and protect your critical services when the traffic tsunami hits. Our goal is to empower you to design systems that don't just survive peak loads, but thrive under them, turning potential outages into massive revenue opportunities. Let's get started and master the mindset of graceful failure and proactive resilience. When we talk about extreme load, we're not just talking about a linear increase in requests. These events, like a major sales holiday or a highly anticipated content release, create a fundamentally different usage pattern that breaks normal assumptions. Imagine a large social network launching a new feature, or an e-commerce platform during its biggest sale of the year. Millions of users perform identical actions within seconds, creating a perfect storm. This leads to critical challenges. First, we see hotspot formation. When thousands of users compete for the same inventory records, traditional database sharding can break down. 80% of requests might target just 5% of your products, creating bottlenecks that overwhelm specific database nodes. Second, cache invalidation storms become a major issue. Rapid inventory updates trigger massive cache invalidations, turning your fast cache layer into a bottleneck as every node tries to evict the same product keys simultaneously. Finally, connection pool exhaustion is a silent killer. Database connection pools, sized for normal load, quickly become insufficient. The overhead of establishing new connections creates latency spikes that cascade through all your dependent services, leading to widespread slowdowns or even outages. Understanding these distinct characteristics is the first step to building resilient systems. So, how do we prepare for these extreme events? It starts with predictive capacity planning. A major streaming service, for instance, doesn't just provision for expected peak traffic during a new show's premiere, they model traffic amplification factors. This isn't just about adding more servers, it's about understanding how a 2x traffic increase can demand 4x database capacity due to cache inefficiencies. Amplification is multiplicative, not additive. Next, we move to progressive autoscaling. For predictable events, scheduled prescaling often outperforms reactive autoscaling. Think of it in stages. 2 hours before the peak, you warm up by prescaling your infrastructure to about 60% of your projected peak. This avoids cold start delays when you need capacity most. 30 minutes out, you engage predictive scaling, gradually adjusting based on early traffic indicators like queue depths, which are more reliable than raw request counts. Finally, emergency scaling is your real-time aggressive response to unexpected spikes or SLA violations, acting as a safety net. This multi-stage approach ensures your system scales efficiently and effectively, minimizing the risk of outages. Beyond scaling, protecting critical services is paramount. This is where circuit breaker orchestration comes in. While standard circuit breakers protect individual services, extreme events demand a coordinated approach across service layers. Imagine an upstream API gateway failing fast when downstream services show distress. This prevents request queuing that would otherwise consume valuable memory and connection pools, protecting the entire system from overload. We also leverage bulkhead isolation. Critical services like authentication and payments get dedicated resource pools that cannot be consumed by less critical operations such as recommendations or user reviews. This ensures that even if one part of your system struggles, core functionality remains available. Finally, graceful degradation cascades allow the system to automatically shift into an essential-only mode when non-essential services circuit. For example, a major e-commerce platform might disable product recommendations to ensure the checkout flow remains performant. Looking at real-world examples, a large e-commerce platform uses tenant-aware load balancing, routing high-traffic merchant requests to dedicated burst capacity instances, preventing viral stores from impacting smaller ones. Another major retailer employs edge computing, pre-caching inventory data regionally to reduce origin server load and improve response times for global customers. These strategies highlight that resource isolation is key to maintaining performance predictability. Implementing these strategies requires excellence in execution. First, load testing that matters goes beyond simple throughput. You must simulate inventory contention, session stickiness, and third-party dependencies under simultaneous load. This reveals the true chaos of real-world extreme events. During the storm, your monitoring needs to cut through the noise. Focus on business-critical indicators, successful transaction rates, P99 response times for checkout flows, and circuit breaker state transitions. These tell you the real story of user experience and system health. And don't overlook recovery preparation. Traffic often drops suddenly post-peak, creating new scaling challenges. Implement graceful scale-down policies to prevent resource thrashing. The ultimate goal is to shift from preventing failures to failing gracefully. Your system will experience partial failures during traffic spikes. The architecture should anticipate this, making those failures boring and automatically handled. Mastering these patterns means architecting systems that turn traffic spikes from existential threats into massive revenue opportunities. So how confident are you now in designing systems that can elegantly handle 10 million users hitting buy now simultaneously?